Alright guys, so what we're going to work on now is we're going to work on the least common denominator. This is the most important setup for the rest of this chapter. So the least common denominator. So after multiplying and dividing, which remember when we multiply or divide, the first thing that we do is we factor when it's multiplication. Then we cross cancel. And then we multiply straight across. Now the only difference when it's dividing is the first thing that you do is you do keep, change, flip, and then you follow the same process. So after multiplying and dividing, we can add and subtract. What do fractions and rational expressions need to have to be able to add or subtract? So they both have to have a least common denominator. Okay, we call this the LCD. The LCD is not the same thing as the GCF. The reason why is the least common denominator is the smallest thing that they have in common with each other, and the greatest common factor is the thing that we pull out. So these are not the same thing. People get these confused sometimes. So the LCD is not the same thing as the GCF. So let's make it real. If I have a fraction of 1 over 2 plus 1 over 3, the first thing I got to do is I got to look at my denominators. If they're not the same, then I have to find my least common denominator. So for 2 and 3, my LCD is going to be 6. Okay, so now what we got to do is we have to make equivalent fractions. So in order to make equivalent fractions, I ask myself, how do I go from, what do I multiply 2 by to get to 6? So 2 times what will get me 6? So 2 times 3 will get me 6, but what I do to the bottom, I have to do to the top. So 1 times 3 is 3, 2 times 3 is 6, so I just made an equivalent fraction. 3 times what will get me to 6? Well, 3 times 2 will get me to 6, but remember what I do to the bottom, I have to do to the top. So I go plus 2 times 1, which is 2, and then 3 times 2, which will leave me with 6. When I have a common denominator with fractions, I leave the common denominator, or my LCD, and then I add my numerator. So I'd go 3 plus 2. So this would be 5 over 6. And this would be that answer. I do understand that people have issues with fractions. So if you do have an issue with it, stop it, rewind it, relook at this, or come and see me and I would love to help you out. And we could practice it a little bit more. Okay? Now, to find the LCD with rational expressions, the first thing that you do is you factor the polynomial and find the prime factorization of single numbers. Okay, remember the prime factorization is just known as your factor tree. So if you just have single numbers, the thing that you want to do is you want to do that factor tree. Step 2, you're looking at each individual factor. Count how many of that factor are in each rational expression. So you're going to ask the question, how many? And then step 3, the largest number you come up with in step 2 is how many you need for your LCD. We call this the max. Okay? So what you're going to do is you're going to have it like a Punnett square. You're going to have like you would in science. So you're going to ask the how many, then you're going to have some term, another term, and then you're going to have the max. And let me show you what that looks like with an example. So I've got 1 over 24 and I've got 7 over 15. So to find my LCD, the only thing I care about is the denominator. Because remember, the least common denominator is the important part. So I don't care anything about my numerator. So I've got 24 and I've got 15. So I've got to find that LCD. Since they're single terms, or single numbers, what I have to do is I have to use the factor tree for 24 and I have to use the factor tree for 15. So we know that 24 is even, so 24 divided by 2 will leave me with 12. 12 is still even, so 12 times or 12 divided by 2 is going to leave me with 6. 6 is still even, so that would be 2 6 divided by 2 will leave me with 3. Remember, the way that you know that your factor tree is done is that you have all prime numbers. Okay, so for 15, 15 is not even, but we know a factor of 15 is going to be 3 times 5, and 3 and 5 are prime numbers, so I'm done. Okay, so for 24, I'm literally looking at 2 times 2 times 2 times 3, and then for 15, I'm looking at 3 times 5. Now, typically, if you're finding the GCF, you find what they have in common and multiply it, but we're not trying to find the GCF. We're trying to find the LCD, the least common denominator. So after using the prime factorization, the factor tree, step 2 is we have to ask how many are in each factor. So how I do this is I look at my results and I individually write them out. So I know I see a factor of 2, I see a factor of 3, and then I see a factor of 5. Okay, so that's literally what I would write. Now again, this is where the Punnett square kind of comes into play, and I have to answer the question. So how many 2's do I see in 24? Well, I've got 1, 2, 3. How many 2's do I see in 15? None. So I put a 0. Alright, for 3, how many 3's do I see in 24? 1. Okay, how many 3's do I see in 15? 1. Then I answer the last question. How many 5's do I see in 24? 0. And then how many 5's do I see in 15? 1. So that's how you fill it out. You just literally ask yourself the question for each term. Alright, now this is where people mess this up. You have to deal with the max. So we're dealing with our max number that we see. So if I cover this up and I am just looking at 3 and 0, my max or my biggest number is just 3. If I look at 1 and 1, my max, my biggest number is just 1. What I see people mostly do, or sometimes make a mistake to do, is they'll add these together. Don't add them. It's just whatever the max number is, so the biggest. Okay, so now I've got 0 and 1, so that would be 1. Okay? So that's how I find my maxes, and it's all based off of what's on the inside. So now what I do is I take each factor and I raise it to whatever the max is. So my base would be 2 because that's my first factor, and I would raise it to the max, which would be 3. I take my base of 3 and I raise it to my max, which would be 1. And then I take my base of 5 and I raise it to my max, which would be 1. So 2 to the third, or 2 times 2 times 2 would leave me with 8. 3 to the first would be 3. 5 to the first would be 5. And then the last thing I got to do is I just got to plug them in my calculator. So 8 times 3 times 5 is going to leave me with 120. Now, I understand you've probably never seen this before, and that is a-okay. I'm just trying to show you a process, and I want to make sure and see this process when you do your homework, because I want you to have it down. Well, this is the first time through, so give yourself grace if that didn't make sense the first time through. Okay, let's look at another one. So I've got 9 over 8m squared, and then I've got 11 over 12m to the 6. Remember, we are trying to find our LCD, our least common denominator. So I don't care about my numerators, I just care about my denominators. I see that these are both monomials, so what I need to do first is I need to deal with this 8 and this 12. So use your factor tree, find your factors of 8, find your factors of 12. For 8, I know it's even, so I can divide it by 2. So 8 divided by 2 will leave me with 4. 4 is still even, so that will be 2 and 2. Remember, the way that I know I can stop is when I have all prime numbers, which 2 is a prime number. For 12, that would be 2, since it's even, and 12 divided by 2 is 6. 6 is still even, so that would be 2 times 3. They're all prime numbers, so I can be done with that. So for 8, I've got 2 times 2 times 2. For 12, I've got 2 times 2 times 3. Okay, so those are my factors. So now what I've got to do is I have to write my factors in. So my first factor that I see is a 2. So I'm going to figure out how many 2's I have. The next factor I see is 3. And those are all my numerical factors. But the last one that I have right here, and you're not necessarily going to have 3, but for this example you do. The last thing I have to deal with is in my denominator is I have to deal with the variable. So I'm just going to write m. Okay? So I found my factor tree, I've written out my factors, and now what I got to do is I got to fill out this Punnett square. So the first thing I got to do is ask the question, how many 2's are in 8m to the second? So for my 8, I've got 3 2's. How many 2's are in 12m to the 6? 2. Alright, how many 3's? So how many 3's do I see in 8m to the second? 0. Okay, and then how many 3's do I see in 12m to the 6? 1. Alright, now, how many m's do I see in 8m to the second? 2. How many m's do I see in 12m to the 6? 6. So, and I literally write those in. Alright, now what I've got to do is I've got to deal with my maxes. So I cover this up. I'm just looking at my maxes, and my max of 3 and 2, my biggest number is going to be 3. My biggest number of 0 and 1 will be 1. And my biggest number of 2 and 6 will be 6. Remember, this is just your biggest number. Okay? So now I take each factor and I raise it to whatever the max is. So 2 raised to the third, 3 raised to the first, and m raised to the 6th. And now all I got to do is clean it up. So 2 to the third, 2 times 2 times 2 is 8, times 3 times m to the 6th. And 8 times 3 is going to be 24, m to the 6th. And now I have found my LCD. Is it tedious? Absolutely, but this process will work. After this homework assignment, I don't necessarily need to see this process, but if you need it, use it. This is a technique that will work every single time. Okay, now what we're going to do is we're going to do a little bit more with the factoring. Same exact process, but we're going to have to factor a little bit. So I've got 6 over x, x to the second minus 4x, and then I've got 3x minus 1 over x squared minus 16. So remember, I'm trying to find the least common denominator, so all I care about is my denominator. So first thing I have to do is I have to factor. Well, I've got binomials. So when I have binomials, I don't need a factor tree, but I do, when I have two terms, I do need to either use a greatest common factor, GCF, or I have to use a difference of perfect squares. So I have x squared minus 4x. So the way that I would do this one is this is a GCF. What they both have in common is just an x. When I pull out an x, I'm left with x minus 4. Okay, the next one that I have is x squared minus 16. So I have two terms, so it either can be a GCF or a difference of perfect squares. I see that 16 is a perfect square, so this is definitely a difference of perfect squares because it's subtraction as well. So I take the square root of x squared, which is x, and I take the square root of 16, which is 4. So I've got x plus 4, x minus 4. Okay, so step 1, factor it, done. Step 2, we're going to ask how many. So I'm going to create it like this. I'm going to go how many, and then right on this side I'm going to put my max. So we're creating a Punnett square even though we don't really have one. And these are going to be the factors that I'm looking at because I've already factored them for myself. So this time I don't have any just numbers, single numbers by themselves. So I'm going to start off and I'm going to just do my first factor of just x. The next one that I'm going to write is I'm going to write x minus 4 because that's the next one that I see. And then the last one that I see that's different is x plus 4. So now what I've done is I've created this Punnett square. Okay, so and now I have to ask the question, how many x's do I see just by itself? So it has to be by itself, so there's only one. How many x's do I see by itself in this factored form? None. Now I've got x minus 4, so how many x minus 4's do I see in this right up here? I got 1. How many x minus 4 do I see in this factor? Okay, I got 1. And then I got x plus 4. Do I see x plus 4 in this first term? Nope. So I'd put a 0. And x plus 4, I see 1. Alright, so now what I've got to do is I've got to figure out my maxes. I filled out my inside, now I have to fill the outside. So if I cover this up, I've got 1 and 0, so my max would be 1, my biggest would be 1. And then I've got 1 and 1, so my max would be 1. And 0 and 1, so my max is 1. So in order to find my LCD, I take each term and I raise it to the max. So I've got x to the first power. If you don't want to write the 1, you don't have to. Then I've got x minus 4 raised to the first power times x plus 4 raised to the first power. So really, my LCD is this right here, because I'm covering each part. It's going to be super important that you know how to do this. Alright, we got another one to practice. So I've got 6 over 5m squared, and I've got 4 over m squared minus 3m. So the first thing I got to do is I got to find my LCD. Remember, we're just dealing with the denominator, so the 6 and the 4 don't mean anything to us. And in order to do this, I have to first factor. So I've got a monomial, so 5m squared. Now the 5 is a prime number, so I can't use a factor tree with that. It wouldn't be helpful. And then I've got m squared minus 3m. In order to factor that, it's two terms, so it either can be a GCF or it could be a difference of perfect squares. And what I see here is I have a GCF, and what I can pull out, what the greatest common factor I can pull out, is going to be an m, and I'm left with m minus 3. Alright, now I've got to set it up, so I'm going to ask the how many. And now I got to look at the individual terms. So first I'm going to see if I have any single numbers by themselves. And the first one that I see is 5. So I'm going to ask first how many 5s I see. I'm sorry. And then I'm going to put my max right here. Apologize. Alright, so I have this term and I have this term. Alright, the next thing that I'm going to look at is my individuals. So I've got individual m's, or individual variables. And then the last one that I have is m minus 3. Alright, so now what I got to do is I got to fill out the inside of that Punnett square. So, how many 5s do I see in 5m squared? I see 1. How many 5s do I see in m times m minus 3? 0. Alright, now I'm going to see how many m's I see in 5m squared. That would be 2. And how many m's do I see by themselves in m times m minus 3? That would be 1. Then I have to ask, how many m minus 3's do I see in 5m squared? I don't see any. And how many m minus 3's do I see in m times m minus 3? That would be 1. Now I've got to fill out my maxes. So if I look at 1 and 0, my max of that is 1. 2 and 1, my max of that is going to be 2. And then 0 and 1, my max will be 1. Okay? So to find my LCD, I take my factor of 5 and I raise it to my max, which would be 1, so you don't necessarily have to write that, times m, raise it to my max, which is 2, times m minus 3 raised to the first power. So this, nothing else to clean up, there's my LCD. Alright, this next one, it is hard, but I want you to try to do it by yourself. So I'm going to set you up, I want you to do the how many, I want you to do the max, okay? I want you to factor them, and then I want you to do your Punnett square. So pause it for a second and work this problem out. Alright, so we got 1 over r to the second minus 4r minus 5 over 3 times r squared minus r minus 20, and then we have r squared minus 10r plus 25. So the first thing that I see is I have all trinomials. So remember, if I have all trinomials, it could either be a equals 1, a doesn't equal 1, or it could be a perfect square trinomial. So for this first one of r squared minus 4r minus 5. This is definitely an a equals 1. So I set up my binomials. I go r, it's minus minus, so that would be plus minus. Find my factors of 5. It's prime, so it's only 1 and 5. They're different, so I have to use subtraction, and I have to get to a negative 4. Okay, so the order is going to be super important. So I'm going to go 1 minus 5 will get me to a negative 4. The 1 has to be positive. The 5 has to be negative. Alright, r squared minus r minus 20. Sometimes it helps to make sure to have your a, b, and c. So if you want to put a 1 there, you can. I've seen that that's helpful in the past. Alright, so this is an a equals 1. So I set up my binomials. I go r, it's minus minus, so that would be plus minus, and I have to find the factors of 20. 1 and 20, 2 and 10, 4 and 5. They're not the same, so I have to use subtraction. I have to get to a negative 1 because that's my b. So I would go 4 minus 5. The 4 has to be positive. The 5 has to be negative. And then the last one I have is r squared minus 10r plus 25. There are two ways to look at this. You could look at it as an a equals 1, or you can look at it as a perfect square trinomial. I'm going to do perfect square trinomial just for a little bit of practice. So how I know it's a perfect square trinomial is my first and my third term are perfect squares, and then my middle term is even. So I take the square root of r squared, which is r. I take the square root of 25, which is 5. Then I go 2 times r times 5, because it has to be even, so 2 times 5 will be 10r. That checks out. So I would do my binomial squared, and I would go r minus 5. If you didn't want to do it that way and you wanted to do it as an a equals 1, you set up your binomials. r minus plus would be minus minus, factors of 25 are 1 and 25, and then 5 and 5. So minus minus to get me to a negative 10, 5 and 5. So you'd get the exact same answer. I showed you both ways. Okay, so we factored it. Now what we got to do is we have to ask the how many. So the first factor that I see is r plus 1. The second factor that I see that's different is r minus 5. And then I see r plus 4. And that's it. Okay? And I've got my maxes. So how many are, so here's my first one, here's my second, here's my third that I'm looking at. So how many r plus 1s do I see in my first set of factored? I see 1. How many r plus 1s here? 0. How many r plus 1s here? 0. So now I'm going to go to r minus 5. So if I'm looking at my first factored form, I have 1 r minus 5. If I look at my second, I have 1. And if I look at my third, I've got 2 r minus 5s. Now I'm going to go r plus 4. I don't have any in my first. I have 1 in my second, and I don't have any in my third. So now I've figured out what's on the inside of my Punnett square. So now what I've got to do is I have to deal with the max. So if I'm looking at my max, I get 1, 0, 0. So my max or my biggest number would be 1. 1, 1, 2. My biggest would be 2. 0, 1, 0 would be 1. Okay, so in order to find my LCD, I take each factor, so the r plus 1, it's raised to the max, so raised to the first power, so I don't necessarily need to write that. Then I've got r minus 5, I raise it to my max, which would be 2. And then I've got r plus 4, raise it to my max, which would be 1. And this is as simplified as it can be. Now, for your LCD, I don't care if the order is different, so if you would have had r plus 4 first, that would have been totally fine. Or if you would have had r plus 1 times r plus 4 times r minus 5 squared, a-okay with me. Okay? So that's about as hard as that one gets. So now, one other thing that I need to cover is problems like this. So if you have 4 over x minus 1, and then you have 1 over 1 minus x, what do we notice about these two? You should notice that they're opposites. And what do we know about opposites? Opposites reduce down to -1. Okay? So when denominators are opposites, this is kind of cool. You can pick either one to be the LCD. So for this one right up here, you could pick your LCD to be x minus 1, or you could pick it to be 1 minus x. I do not care. Either one is 100% correct. Okay, so if you see that you have opposites, when you have rational expressions and you're trying to find the least common denominator, you can pick either one of those and it'll be 100% correct. This will be important for your 7.4 notes. So please keep that in your back pocket. Alright, then the last thing that you have to do for your homework is you have to make equivalent rational expressions. So when adding or subtracting fractions or rational expressions, after finding the LCD, you must take each fraction have that new, or you must make each fraction have that new LCD. This is called making equivalent rational expressions. Now we did this on the first slide. It only changes the appearance of the rational expression. It doesn't change the true nature. So what I mean, if I have like 1 over 4 plus 3 over 8, okay, remember when we're adding fractions we have to have the same denominator, or the LCD. So my LCD of 4 and 8 would be 8. Remember, if I need to go through the steps for this, I find my factor tree of 4, so that would be 2 and 2. Factor tree of 8, which would be 2 and 4. And then break it up to be 2 and 2. So for 4, I just have 2 times 2. For 8, I have 2 times 2 times 2. So if I'm looking at my factors, I only have 2, and I have to ask myself how many. So how many 2's do I see in 4? That would be 2. How many 2's do I see in 8? That would be 3. Therefore, my max would be 3. So to find my LCD, I would do 2 to the 3rd power, which would be 8. Okay, so if you needed to see it, there it is. If you knew that 4 and 8, your LCD was 8, okay, I'm sorry. Now, how do you go from 4 to 8? What do you have to multiply by? You have to multiply 4 times 2 to get to 8. What you do to the bottom, you do to the top. So 2 times 1 would be 2, 4 times 2, which would be 8. But if I was to reduce this down of 2 over 8, it would give me 1 over 4. So this is just called making equivalent rational expressions. So then, just because I cannot not finish a problem, so at 2 over 8 plus 3 over 8, I keep that LCD of 8. I add my numerators, 2 plus 3, which would give me 5. Okay, and I can't reduce it at all, so I'm done there. So all we're doing now is we're going to be changing the appearance. We're not changing the true nature. This is going to set us up really well for 9.4, and you have a couple homework problems in 7.3 on this. So how to make equivalent rational expressions. Step 1, you have to figure out what you have to multiply the old denominator by to get to the new denominator by, or to get to the new denominator. Okay? Then you multiply the old numerator by the answer to step 1 to get your new denominator. So just like what we did over here. And we're going to practice again with some fractions. So step 1, you have to figure out what you have to multiply the old denominator by to get to the new denominator. So I have to go 8 times what will get me to 40. So we would multiply by 5. What we do to the bottom, we have to do to the top. So I'd multiply by 5. So how I want you to show it is I want you to go therefore. This is a mathematical symbol notation. It means therefore, and it's just a triangle with 3 dots. We go therefore question mark equals 3 times 5, which would be 15. And I do want you to show this for your homework because you need to get in the process of showing things mathematically true. Okay, so that's with the fraction. Now let's do it with rational expressions. Remember, the only difference between a rational expression and a fraction is that you have variables. So how do I go from 5 to 30k? Well, I definitely know that I'm going to have to multiply by the k. And how do I go from 5 to 30? I multiply by 6. What I do to the bottom, I have to do to the top, so I'm going to multiply by 6k. So I'm going to go therefore, question mark equals 7k times 6k. And 7 times 6 will be 42. K times k is k squared. I box my answer. Okay? I do need to see this work. I don't want to just see 42K because I will assume that you copied it from the back of the book. Alright, so now we got 12p over p squared plus 8p equals question mark over p to the third plus 4p squared minus 32p. Alright, if I initially look at this, I'm like, there is nothing that's going to get me from there to there. But what I can do is I can factor it, and once I factor it, it will become very clear. So focusing on my denominators, if I have p squared plus 8p, I've got two terms, so it either can be a GCF or it can be a difference of perfect squares. This one is a GCF, and what they have in common is going to be the p. And I'll be left with p plus 8. Okay, then for this one, the first thing I see is I have p to the third power. So we definitely know that we have to pull out some type of GCF. So we can pull out a p, and I'm left with p squared plus 4p minus 32. And then I could see that this is an a equals 1 because I have three terms. Alright, so I've got my p. I set up my binomials. I go p plus minus, so it's going to be plus minus. And then I have to find the factors of 32. So when I find the factors of 32, it's 1 and 32, 2 and 16, and then 4 and 8. The signs are different, so I have to use subtraction. And I have to get to a positive 4. So I'm going to use the 4 and the 8, and the order is going to be super important. So I go 8 minus 4. Now it's a lot clearer. So now I have to ask myself, how do I go from here to here? What do I have to multiply? Well, I see that they have the exact same thing of p times p plus 8. So the only thing that's missing is this p minus 4. So I'm going to multiply by p minus 4. And remember, whatever I do to the bottom, I have to do to the top. So I've got therefore, and let me put that in parentheses. I go therefore question mark equals 12p times p minus 4. And this is perfect for me because we're dealing with rational expressions. And since I'm dealing with rational expressions, do I have to distribute that? Not yet. You will when you get to complex fractions. Alright, and that is 7.5. Alright guys, so now what I need for you to do is I need you to do your 7.3 homework from your pacing guide. And if you have any questions, please make sure that you bring them into class and we will work through it from there. Thank you.